Hi everybody. Today we're going to talk about line graphs. I'm sure that you all have made line graphs and you know what they're like, but biology is going to have some special new rules that we have to deal with. So I'm going to take you through the basics very quickly. First of all, this thing right here in this picture is not a graph. That is a table. When you have the rows and the columns, those are tables. Tables are a great way for organizing data that we can then transfer into a graph. But the graph is the thing with the grid, with the dots, and they'll connect the dots, right? So the line, that's a line graph. All right, so the first column right here, what's labeled here is temperature. The first column is almost always got the independent variable. Remember, that's the thing different between the two groups. In this case, we apparently have one group that is at one temperature and then some other groups at another temperature. The independent variable is the thing that's made different between the groups. The other column is the dependent variable. In this case, the number of beats per minute may depend on the temperature. And so we have the dependent variable in the second column. In a table, each column should be titled and should have the units. So temperature in degrees Celsius and heart rate in beats per minute. Ordinarily, in a table, you will have the numbers in the independent variable in either ascending or descending order. So here we have 5, 10, 15, 20, 25. That does not mean these numbers will be in order because perhaps the heart rate gets higher and higher with greater temperature until you get to a really high temperature and then it drops for some reason. So you will not necessarily see the numbers in order on the dependent variable, the second column, but you should have them in order in the first column or the independent variable. All right, so that's a table. And now this is a graph. So this is a line graph. We have numbers on the y-axis and we have numbers on the x-axis, and we've got a line that's been plotted out. That is a graph as compared to the table that we saw before. All right, so remember that the independent variable on the table went in the first column. Well, the independent variable on a graph goes on the x-axis along the bottom. So the first column of a table usually will be on the bottom of the graph. And the dependent variable generally goes on the y-axis. So in other words, the second column will go on the y-axis. And so we have the independent variable is on the x-axis and the dependent variable is on the y-axis. All right, so we will put the scale out in numbers across the x-axis and scale up the y-axis, and then we'll find where they intersect. So for example, the temperature is 5 degrees Celsius. So we'll find the 5 degrees Celsius on the x-axis, and the heart rate is 108 beats per minute. So we will go up, we'll find 108 beats per minute and put the point. And we will do that for each of the points and connect them. Some key things that you must know: the numbers go right against the line. They don't go in the spaces in between. So in other words, this 5 is lined up with the line right above it, right? The 5 is lined, we don't put it in the box, it goes on the line. Generally, we don't put a 0. The person who made this graph kind of did a lousy job because they put that 0 in. We generally will leave it off. Most of the time, when we make graphs, even if there is data for 0, we won't write the 0 in because almost always students make mistakes with the 0 that end up costing them points, and you don't have to have it there. So we'll just not put a 0 on almost every circumstance. All right, so let's look at this graph. Let's see what's wrong with it. We have a series of numbers along the independent variable or the x-axis. Time in hours, independent variable, x-axis. So that's right, we put the time here, we put the time here. We have the y-axis, the dependent variable, the number of specimens. That's right. So let's look at it. What is wrong with the graph? Well, it looks like we have specimens have to get up to number 2. It does that. It goes from presumed 0. Notice they didn't put the 0 on there. That's good. And then they have a 1 and a 2 and a 3. And those are written on the lines, not in the boxes. So that's right. And we have an x-axis, and it has to go up to 10. And it does. It goes 2, 4, 6, 8, 10. And then they plotted the points. But there's something wrong on the x-axis. Take a look really carefully. You see that point right there? That is the presumed 0. Where we plotted data for 0 was 0.5. 0 was 0.5. That 0 is only 1 box away from the 2. So for the first 2 hours on our graph is 1 box. What about the next 2 hours that pass? How many boxes are representing those 2 hours from 2 o'clock or 2 hours to 4 hours? 2 boxes. So our scale was 1 box big for every 2 hours and then suddenly became 2 boxes big for every 2 hours. You can't do that. Bad. Not going to get you credit. It's going to make the relationship between this axis and that one look wrong compared to what it actually is in nature. So it went 1 box for the first 2 hours and then it went 2 boxes for the next 2 hours. Can't do that. So instead, the x-axis should have looked like this, where we had our 0 and then you go 2 boxes and then you go 2 boxes, and then you go 2 boxes. The other alternative is you could have gone every box. You could have gone 2 and then 4 and then 6 and then 8 and then 10 and squished it all up, right? Or you can go every 2 boxes, 2 and 4 and 6 and 8 and 10, but you can't change the pace at which you go across the numbers. All right, how about this one? Now this one has it right. It goes 2 boxes and 2 boxes and 2 boxes. And that looks right. And it goes 1 box, 1 box, 1 box. That's right. So they went by 1 box up the side. They went by 2 boxes down the side, the x-axis. So what they do wrong? Well, look at this. 3 is 2. 4 is 3. They plotted them right. 6 is 1 and 10 is 1. So they plotted that right. But is there a 0? Do we know how many specimens there were at time 0? Do we know there were no specimens? No. And they connected that line there to the origin. You can't do that. You do that in math. You can't do that in science. We don't know that there were 0 specimens at 0 hours. And so that entire section of the line is wrong. Instead, it should have been done like this, where we don't plot, we don't connect to the 0. First was 3 is 2. 4 is 3. 6 is 1 and 10 is 1, and then connect the dots. And so what was done wrong was they assumed a 0. Do not connect the line past the points that you plot. Only connect the line among the points that you are plotting from the data, and don't extend it beyond that unless you're told to do that in the directions. And that is the basics of line graphs and the little bit of twists that go with Regents biology.